Hello, everyone. Welcome back to SAT Math Question of the Day. Here we have a question. Please try it. Pause the video. Come back, and we'll do it. We'll go over how to do it. Okay. Just setting everything up here. Okay. So there's our question. So we have 9x plus 3 is cx plus 3 plus 4x. They want to know what c is. For what? Oh, no. For what value of c does the equation have infinitely many solutions? Well, if you combine like terms, 9x plus 3 is equal to 4 plus cx plus 3, well, you would have to know that if 4 plus c equals 9, then you're talking about the same equation. 9x plus 3 equals 9x plus 3, and x really could be anything. X can be 1,
you're talking about an equation that says two expressions are equal.
Right.
An equation that says the equation that you get when 4 plus c equals 9, you get an equation that says that the same expression is equal to itself.
Right. Which means
you don't get two equations are equal.
Is that what I said?
Yeah.
Oh.
What you get is an equation. With the left-hand side, they're the same.
Right.
Okay?
Right.
So no matter what value you plug into x, the result on the left is the same as the result on the right. And so any value you plug into x is a solution.
Right.
Therefore, and we're talking about numbers of which there are infinitely many. And so in this situation, the equation has infinitely many solutions.
Right. Yeah. I sort of factored here. I hope that was okay. I hope people saw what to do there. But if you don't factor, you have to notice that the c plus the 4 have to equal the 9. Those are the like terms.
Right.
So
what I thought here is that I have to make c such that when you add such that cx plus 4x equals 9x, and that happens when c equals 5.
Right. Yeah. So you don't really. I took away the circle because it
plus 3 plus 4x.
Yeah. Right. The one thing you have to notice is there's a plus 3 on both sides. If there wasn't a plus 3 on both sides, then there'd be a problem with the problem. But there's a plus 3 on both sides.
If the two threes were not the same, they weren't. If you had a different number like 4 here, then what you get is an equation that has no solutions.
Right. Yes, that's right. But that's not what they're asking. Right.
Yeah, that's not what they're asking.
That's not what they're asking. Now, when I said the two equations are equal, you know what I was sort of thinking, just to justify.
I know what you meant. Of course, I knew what you meant.
You're right. You know what I mean.
But in math, we should try to say what we mean.
Yeah.
Not mean something and say something else.
I totally agree. But one can write both of these as equations. Y is equal to 3 plus 9x. And y is equal to...
okay. Oh, there we go. Yeah, there you go. Yeah.
Plus 3 plus 4x. Now you could justify that the two equations would have to be the same, right? So maybe that's what I was in my head.
Well, now you're converting it from one equation and one unknown to two equations and two unknown, where the two equations are the same.
Right, which one would not do. But that would probably by my brain.
No, that's what's simply happening is, what you're simply happening is you're finding a value of c for which the equation that they give you, when you substitute that value for c, the equation that you turns into a particular kind of equation, an equation with a special property. That property is the property that the equation is an identity.
Yep.
Right?
Yep.
An identity is a kind of equation where whatever value is plugged in for the variables on the left, if the same value is plugged into the variables on the right, then always the two sides are equal.
Right. Yeah.
Right? So an example of an identity in trigonometry is sine squared of x is equal to 1 minus the square of the cosine of x.
Right. So no matter what x is, it's always true.
Yeah.
Yeah. Now, these things happen, well, ignoring this for a second, going back to the linear side, you get weird things like infinitely many solutions or no solution only when there's an x on both sides. If there's not an x on both sides, then you can always solve the equation. Like 3x plus 7 is 9.
Okay, here's an equation where there's an x on one side, there's no x on the other side, and you have infinitely many solutions.
Okay, right. Yes. Yeah, okay, fine. So Seth...
Of course, what's going on here is that the left-hand side is equivalent. It's identical. There's an identity of the left-hand side to 3.
Right. So after you simplify equations, then in their simplest form, if you have an equation in its simplest form with an x on only one side, you're not going to have this problem where you're going to have infinitely many solutions or no solutions.
Well, another way to look at it is that in a general linear equation with a constant right-hand side in two variables, right? They have ax plus by equals c. If a equals 0, right?
Yeah.
No, we have a y there. Yeah. If a equals 0, then if there's a solution for y, then there's an infinitely many solutions, including that solution for y and the values of x. Right. So if the coefficient of the variable is 0, and the variable occurs in only one term, then if there are any solutions at all, there are infinitely many. Why? Because 0 kills off 0 times anything. If this were 0,
yep,
0 times x equals 0. So this just remains the same number no matter what. And right, so whether the equation is true depends on y.
So basically, on the graphical side, you get a horizontal line. Y can be a number. Y is equal to c over b. So let's say it's 3. Y is 3. So for all values of x, when x is 1, when x is 2, when x is 3, you're always going to get the y. You're always going to get y is 3 always for all x. And that's exactly what Seth's saying, except here you see it graphically as opposed to algebraically, which is important on the SAT to be able to look at different problems, to be flexible enough to look at problems from different lenses, both the graphical way and the algebraic way. Okay, so maybe we should check their answer. Let's see how they do it. Okay, clear all drawings. Stop this, and we say it's 5. So let's see. Good. And then see how they do it. How get a no? Yeah, okay, get a hint for the problem. Wait, in order when we do the get a hint for a problem, we have to just do all the hints. And now we can look at the answer. Okay, so it only has 3 steps. First, we observe it's a linear equation. Linear equation, one variable, having infinite solutions. When the equation reduces to a statement that's always true, that's what Seth said, an identity. You combine the like terms. I mean, you set the coefficients of the like terms to be the same.
Aha! Here's an example of telling when the two sides are identical, meaning when the corresponding coefficients are equal. Aha!
Yeah.
So thing we touched upon yesterday.
Yeah. Oh yeah. Okay, and then we basically they do it the same way we did it. C plus 4 is 9, so C is 5. Okay, so not much more to be learned from that. So I guess that's it. We have just, if you have people who have been watching this for a while, we are now on our third cycle of repeating the Khan Academy digital SAT course. We go through one question of each type. We're starting our third cycle today. So I'm Joel. I have a PhD in mechanical engineering from Columbia. Seth has a PhD in math from MIT. He's a professor emeritus at SUNY Albany, who taught computer science for many years. We are here to hopefully offer different approaches on how to do the SAT math questions. And we advocate in terms of studying for the Math SAT to go to Khan Academy and just take one of their digital courses, either the course that prepares you for the digital SAT or a course for the non-digital SAT, although the non-digital SAT is going to go goodbye soon in the United States, and just do those questions. They offer maybe 600-700 math questions, and they partner with the SAT people, so these questions are sanctioned by the Math SAT, and after 2016, the Math SAT tests more of what you learn in school rather than anything else. So it's important to know what is on the test, and Khan Academy will give you that topic list. So, and if you're done with that, then go to the SAT College Board and take as many practice tests as they offer. And please dislike our video. Comments are more than welcome. We appreciate the comments. And if you have any Math SAT questions, please email them to us at satmathquestionoftoday@gmail.com. I think that's it for today, right?
That's it. That's all,
it
folks.
for today. Okay. Have a great day, everyone.
Thank you.